Hi, and welcome to the AP Biology Lab 10 Physiology of the Circulatory System podcast. There are actually two parts to this lab. The first part, you use a sphygmomanometer, and that's a mouthful, but a sphygmomanometer is that cuff, that pressure cuff and stethoscope that they put on you whenever you go into the doctor's office. It's a quick way to judge general health of your circulatory system, and so you should understand the concept of essentially how it works. The other part is actually studying the circulatory system. Now, normally AP classes use Daphnia to study this. There's a heart in the Daphnia, and so you can just look at it and look at the beating, and then you can change the temperature. We actually do this with goldfish, and we decrease their temperature and observe how that affects their circulatory system. And so let's look at the sphygmomanometer. Sphygmomanometer is essentially two parts. There's a cuff, and that cuff can increase pressure on your arm. And so it's going to squeeze on your arm, and it squeezes on your arm up above, and then you listen down below. And so there's a stethoscope at the bottom that's listening for that blood moving through the artery. And then we squeeze it until we eventually get rid of the sound that's coming through. And so there's two terms you should be familiar with. The first one is systolic. That's your top number. And then we have finally diastolic. Now, systolic is the contraction of the ventricles in your heart that's actually making that. And the diastolic is just simply the pressure of the arterial walls. Now, how does it sound? Well, we have what are called the sounds of Korsakoff. And so let me try to do this. Essentially what you do is you listen at the artery, and then you'll increase the pressure, and then eventually you'll decrease the pressure. Let's say we crank it up to around 150, and then as you listen, as you slowly let go of the pressure, this is what you'll hear. You don't hear anything, and then all of a sudden you'll hear and so you'll hear the sound, and that's the sound of the actual ventricles of the heart pushing that blood through. We've lessened the pressure so the blood can now get through. And so this is what you hear as you decrease it. You remember the number at the top when you first hear the sound, and then we just let it go, and it'll sound like this. And then it'll go away. And so that bottom number is the point at which we don't hear any sounds of Korsakoff. And so that's going to be the lower number, or the diastolic number. And so it's a quick way to measure the pressure of the blood within the vessels of your body. So what might affect that? Well, first of all, that when you've probably noticed this, when they send you into the doctor's office, they have you sit there for a long period of time, and that's because they want your blood pressure to decrease. And so your blood pressure is going to decrease when you're in a sitting position. If you stand up quickly, then you're going to increase your blood pressure, and that's because you simply have to pump that blood and make it all the way up to you as you're standing up. If you start to exercise, we're going to require more oxygen in the cells around your body. That's going to increase the pressure as well. And it's really a quick way to judge how fit a person is. In other words, if we have them do exercise and then stop, we can look at how long it takes for that blood pressure to return to normal, and the longer it takes, the more unfit that individual is. And so why is blood pressure a big deal? Well, let's say you have hardening of the arteries, or a decrease in the pressure of the cross-sectional area of the vessels. That's going to indicate that there's some blockage, and just like putting your finger on the front of a hose, it's going to increase that pressure. So that's the first part, using a sphygmomanometer and understanding how it works. The second part, we actually study goldfish. And so in this, what we do is we put a goldfish in a tank. We try to eliminate all the extraneous like stress and movement around them. And then we measure their respiration rate. And we measure their respiration rate by counting their operculum movements per minute. Now the operculum, remember, is going to be this gill covering. And essentially, as a fish breathes like that, it's opening its mouth and it's moving its operculum to move water over the gills. And so the more times it does that in a minute, the more quickly their circulatory system is working. And so what we do is we decrease the temperature gradually. And so we'll measure the operculum movements per minute at, let's say, 27 degrees Celsius, and then we'll gradually lower it down, measuring it every few degrees, getting 10 measurements, and then bringing it down to maybe 3 degrees. And so we look at how the respiration rate changes. and it's pretty cool and pretty noticeable. Eventually, they'll almost park it on the bottom of the fish tank, and they won't move at all, and there'll just be a few movements of the operculum in a minute. And so, what would happen? A better way to think about this is what would happen if we put something else inside there, something that is a mammal. Let's say we put inside there not a tank but a cooler, and inside there we put a mouse. Now, a mouse and a goldfish are different in that a mouse is endothermic and a fish is going to be ectothermic. And so with the goldfish, we'll see that as we decrease the temperature from 30 all the way down to around, in this case, 0 here, we're going to see a decrease in their respiration rate, and it'll actually kind of eventually level out. But if we do a mouse again, we're going to find that its respiration rate is going to be pretty much constant. And the reason why is that they are endothermic. In other words, they maintain that constant body temperature, whereas a goldfish, its body temperature is set by its surroundings. And so as the surrounding temperature slows down then or cools down, then their body does, and thereby all their metabolism as well. So how do you get warm again? You're something like these turtles, and you're going to sit in front of the sun, and you're going to wait basking in the sun until the heat of that sun warms you up and your metabolism can warm up. So that's the 10th lab, and I hope that's helpful.